Good evening to everyone. Today we would like to present about assignment. The topic is pressure in pipe. So my teammates is Ahmad Abdullah, Muhammad Afizin, and Nur Aisha. Next. Okay, for the introduction, fertigation is one way of growing vegetables with advantage of minimizing amount of watering. There are some examples of configuration which will give variation in terms of flow rate as well as the volume of water received by each plant. This presents about the experiment of two types of pipe configuration, which is the straight line and closed loop. This investigation is carried out to analyze pressure variation in hose pipe over a specific pipe length with two different configurations by performing experiment and simulation through exercise in hose pipe. Based on the experiment, there are two types of tasks that our team had to do. First, we need to do type two type of configuration applicable for watering process, namely straight line and closed loop. The first tasks are done to know maximum flow rate, velocity, maximum achievable water jet, and maximum pressure in pipe. For the second task, we need to install and analyze 16, then generate the two type hose pipe configuration. Okay. Then perform the CFD simulation. Okay, next I handle to Muhammad Abdullah.
Okay, for the methodology for experiment straight hose, by using the hose pipe, cut it for 2 meter. Next, make 5 holes on the straight hose pipe and measure the diameter of hole. Use stopper at the end of the pipe to prevent water from flow out. Next, open water tap until maximum and measure the height of water jet on every hole by using measuring tape. Okay, for the experiment closed loop hose, by using 16mm T connector, do connection as shown in the figure. Next, make 10 holes on the straight hose pipe and measure the diameter of the hole. This is the final view of the closed loop hose. Lastly, open water tap until maximum and measure the height of water jet on every hole by using measuring tape. Next, data and calculation. The time taken for the water pressure from the ground to the water jet is 2 seconds. The maximum height water jet is 0.16 meter. The tube diameter 14 millimeter. The area of the tube is 0.0154 meter square. The velocity of water pressure is 0.08 millisecond. The flow rate of the water is 1.232 times 10 to the power of negative 3 meter cube per second. Okay, there are two different pipe configuration. This figure A, straight hose, figure B, closed loop. This is data for straight hose and closed loop hose. Okay, next we measure the velocity and flow rate for straight hose. This is for hole 1. The velocity is 0.205 and the flow rate is 5.781 times 10 to the power of negative 4. This for hole number 2, the velocity, the flow rate, hole number 3, hole number 4, and so hole number 5. Next is velocity and flow rate for closed loop hose. As you can see for hole number 1, 2, 3, 4, and 5, until hole number 10. Okay, next discussion.
For discussion, Bernoulli principle assumes that an increase in a fluid speed occurs at the same time. It describes the inverse relationship between pressure and speed at the area in a fluid. As the flow rate increases, the pressure in a fluid stream decreases. It may seem counterintuitive. The areas where the fluid is moving quickly will have lower pressure. A fast-moving fluid tends to generate more pressure on body than a slow-moving fluid. However, we are now analyzing specifically to pressure, the internal fluid pressure that would be exerted in all directions during the flow, including on the side of the pipe. The pressure that Bernoulli principle is referring to. This is not same as the pressure that a fluid will apply to you if you stand in the middle and stop it from running. Uh, last, I pass to Fizin.
Okay, my name is Muhammad Hafizin Arif bin Tajuddin. For the last part of this presentation, I will explain the conclusion of this experiment. Throughout, throughout the experiment conducted, it is observed from the calculate section where the flow rate, water jet, and pressure in closed-loop hose are much lower than the straight-line hose. From the result obtained, we can conclude that Bernoulli equation is valid for flow as it obeys the equation. As the flow rates increase, the pressure will decrease. We observe that when fluids move at higher pressure to lower pressure, the velocity will increase. Although there are small differences between the speed of the flow and the pressure when we use Bernoulli equation and linear fluid flow equation to calculate velocity. However, we conclude that the experiment was valid enough to prove Bernoulli theorem of pressure in pipe. Some of the error incorporated was due to random error as well as the factors not taken into account in Bernoulli equation nor experiment, such as hole error in pipe, the main pipe pressure was not consistent, parallax and systematic error, such as measuring the height of water with eye level or frictional losses. And lastly, the experiment was successful and the objective was are obtained. That's all from me. Thank you.